Just because you have a tool that you can run doesn't mean that those dials that you're turning, if you're not turning them right, you're still getting crap, right? Crap in, crap out. So if you don't understand what you're doing, you can end up with failures. That's the whole point about what's good about it and what's bad. The good part is, all of a sudden everybody cares. The bad part of it, now you put a tool in everybody's hands, now everybody thinks they can run an energy model. Some can, some can't. And the thing is, you have to kind of team up with people who know what they're doing because they can guide you. Because just because you turn the dials doesn't mean you won't end up with crap. So for example, who was it? Mike and I were talking last night, right? So this seems what's really German to me, right? Because like you asked me, like in the spreadsheet about the Windows, the new 2012 version, I can put the psi values at the top and the bottom, and like the, oh look, there's 0.003 less BTUs. I mean, it's ridiculous, right? That you would have, that kind of precision, and then for the thermal conductivity of Earth, it's just some random number, and you can change it to whatever you want, right? I mean, it's like, that's a really huge deal, thermal conductivity to the Earth, and I live in the only reason I even know about it is because we had geothermal systems that we installed 15 years ago that lost efficiency over time. Why? Because of our soils.
And that's an example. Michael Blasnick knows a lot more about this than I do, but he convinced me that the unknowns when you're energy modeling are rather huge. The soil conductivity is one, window shading is another, because nobody really knows the tree next door and how fast it grows and how the angle of that tree changes over time, even though some people do their best, and some people just guess, and some people don't do a shading study. And nobody knows if they're pulling the curtains or not, but that has a huge effect on window performance, much more than those tiny little edge details that the side detail entry implies. So extreme precision with an extremely precise result when there's 2 or 3 huge fudge factors are misleading.
There's way more than 2 or 3.
And there's no real solution to that. But I mean, it still may be a useful. But I'm going to say what I think is physics and what isn't physics. And I think a lot of people misunderstand this. I think the Dr. Feiss often made assertion that the 0.6 ACH50 is necessary to prevent deterioration in a wood-framed house is not physics and is not true. And many people have simply stated that as gospel and repeated it because he said it in print. I think also the basis that we have this air changes per hour in Europe, and we can get only so much heat through the ventilation system, and that is the space heating limit of 15 kilowatt hours per square meter per year. That fiction or that birth story or that creation myth as somehow a physics-based interpretation of this is meaningless because nobody anywhere in the US delivers space heat through the ventilation ducts, and it doesn't even matter. And even if somebody does in Europe, it's becoming increasingly irrelevant because of ductless mini-splits, which are an excellent way to deliver space heating and cooling and have nothing to do with ventilation. And so that many people cling to and misunderstand, and they think that that means that the space heating number is based in physics. So it drives me nuts.
One other thing I want to say about that, though, that another thing that was brilliant about Dr. Feiss, and it's a marketing thing, right, is that he put out 3 simple numbers. I don't care where he grabbed them from. I don't care how he got them. The fact that he was able to make it boil down to 3 performance-based numbers that you could somehow get to, voodoo, magic, however you get there, and just put it out there that this is a standard, has opened up 47 countries to doing things that they weren't doing. So for whatever, the criticisms and all this, the bottom line is he's making the world, the whole thing, the whole Pascal standard is making the world a better place, and we need to, some people need to get certified just to keep it going. But it's going to be the same thing. There's probably a ton of people building buildings that are passive house, close to passive house, a little over passive house. They're building way better buildings because of what his work is.
All right, so I got one more question. I'm going to turn it back, open the room pretty soon, but I've had a couple corked up. One is, there's this level of, somewhere there's a curve between research projects and mainstream adoption of these techniques. And, Chris Corson showed his first Passive House Day, which was Chris Corson's research project. His personal, trying all this stuff out. And, his second one is twice as fast, his fourth is 5 times as fast. So, every builder goes through that curve when they decide to change their culture. So, where is this group, perhaps the New England group, on that curve between research and mainstream adoption? Any opinions on that?
Way ahead of Virginia.
All right. Are we still in the research phase? Are we baby steps?
I think if you're doing a blower door test to understand, if you're over and over again doing blower door tests with all your sheathing on, because you have to convince yourself that sheathing doesn't leak, then once is a research project, and more than that, to me, isn't that useful. So I think the Duclos method, the first time, it's probably very good. It's useful. And then after that, you want efficiency in construction. So you probably wouldn't test it again before the windows are in. I never test a building before the windows are in, unless it's a large building, in which case I arrange to get the windows in a corner early. I want some windows in a room that I can close off with poly, throw a blower door in there and a scanner or a fog machine, and verify that the implementation of the details are working. And that's particularly true with a new, working with a new construction group.
Absolutely.
Right? So, but for Adam, well, for like, you know, I've watched in the passive house that I worked on in Brattleboro, I watched the folks who come to do the FIAS Plus thing spend 2 hours doing this blower door. And these are really smart people because they have to meet the ResNet standard for 5 pascals minimum offset, whatever it is. I'm not a ResNet person. It was windy. The numbers are between 70 and 90 CFM50 on a building that's probably 2,000 square feet. I'm gone by the time, you know, if I'm at the bare, if I can barely get the building right with a C ring and I really need a D ring,
You're good.
I care about plus or minus 20 CFM50. So on our buildings at South Mountain, I don't go in there and tape anything off. Right? I go in there, run the blower door. If it's 100 CFM50, I go home. I go back to the shop. How much more are you going to improve the building or learn? So that's a research project to me. If you feel like you have to be there for 2 hours, there are other ways you could spend your time.
There are other ways.
But make sure you're doing the follow-up. So one of the things that's come out of this, again, Mike's doing this a lot with the e-monitors, and Peter Schneider is monitoring more things than could make your head spin. But we are, as a community, doing much better with actually looking how the buildings work. And that is ongoing research. I have always called that unfunded research. I have tens of thousands of dollars worth of unfunded, probably hundreds now, of unfunded research. So if you want to know how what you did works, measure it.
Right.
And that's always research.
Yeah,
Is there any opinion, Mark, on that?
Well, I would, you know, the Pretty Good House people in Maine who started this discussion have led me to believe that I hope we get to the point eventually where we can build airtight enough, put in 1 or 2 ductless mini splits and go home. You know what I'm saying? We're coming down to a consensus in New England of what it looks like. It's a compact envelope, like you say, 2 shoe boxes. It's got, you know, half its windows on the south and none on the north and a few on the east and west. It's got the right overhang. It's got double stud walls filled with cellulose and triple glazed windows. You know, we know how to do it. So we don't have, I think running the PHPP for every single house, you know, and I don't want to hit those numbers. If you can heat it with 2 mini splits, who cares? You know what I'm saying? Okay. It's good enough.
That's the sign. All right. When these things are adopted as commodity items, in the same way that builders adopted 2x6 stud walls after 2x4s. Right. You know, like they just did it. So, okay. All right. I got one more question before the crowd, and that is, the biggest problem we have in getting passive houses built is that we put a set of scenarios up in front of a client, a contractor, whoever. So, you know, like, I showed passive house and low energy, and then I'm going to have code, and I have that. And 90% of the people pick the one over from the one on the right.
You need one more then.
I would like, really quickly, a name from each of you for what we should call a thing that's harder than passive house.
Impossible house?
To put on the impossible house. All right. Okay.
Impassable house.
I'll look that up in German.
I mean, right, I guess after they invented the zero energy house, they invented the positive house. So I guess that there's no end to you know, double positive, triple positive, quadruple, I don't know.
Super plus good. Wasn't that an Orwell thing? All right, Mark?
I have no idea.
Come on, you're not trying. What would an even dumber thing be? All right.
Now we have to go to the U.S. Senate.
Okay.
Kind of stemming off the construction industry, I was just wondering where you guys think we are in terms of building materials that are available to us. From my perspective, it seems like the HVAC systems and some of the systems in the houses that we're building are becoming more simplified, but our walls becoming more complicated and bigger. And what do you see the future of building materials? How do you think that they're going to be developing? More like framing materials.
I think there's a physics rule about R value, which is, you know, you don't really get much above R 6.5. You might hit R 7 with, you know, that's the physical fact about insulated materials. So if you want an R 40 wall, you know, I don't believe that the aerogel or the vacuum insulated panels are going to save us. So I think we're stuck with fat walls and fat ceilings. That doesn't necessarily mean they're complicated. I think double stud walls aren't particularly complicated. And I think if you give them a rain screen and probably choose plywood over OSB, they're pretty durable. You know, I don't think we're going to have a rash of failures of double stud walls. So, you know, I think the materials we have, I actually believe we have, quote, good enough materials. I've always said it's not the new gadgets we need. It's using the gadgets we had 30 years ago, right, you know. And I love ductless mini splits, that's wonderful. I love the slightly better triple glazed windows, but I don't think we need windows from Europe, you know. I think we can build really good houses with what we've got, and most of the stuff we had in 1985.
All right, I'm going to close with just a quick one, which is, can each of you just mention what your favorite building you saw last year was? And on positive, Jan.
My favorite building last year was the picture that Joe Stiebrick put out of G.D. Gang's building.
Oh,
Wave
the
building.
radiator in
The
Chicago?
radiator in Chicago. That was my favorite image of
The
last
skyscraper
year.
next to Millennium Park?
Yes.
All right. That's the famous one that has cantilevered concrete balconies that all are a thermal bridge, and it's gorgeous.
Building, isn't it?
What's that?
Isn't it a lead building?
Oh, yes.
All right.
And it won all kind of awards.
Anyone else?
Are you talking about a new building?
No, just favorite building.
Well, that's a really easy one for me, especially being here in Boston.
I'm trying to ask you
The
an
MIT
question.
chapel by, you know, what
Saarinen.
could be better than that Saarinen building? Is there a better building on the planet? I don't think so.
All right. Martin, any
No
favorites?
insulation.
Any favorites last year?
No insulation.
Well,
It has sparklies in it.
I was thinking of a new building. I mean, I really like what Carter Scott is doing in Massachusetts for his $200,000 houses. And, you know, his first one was a nice 2 ductless mini split building. And he's built several since that are all basically the same. They're rectangular boxes, but he's really doing a great job for $200,000. And that's really encouraging.
I'm going to make a plea, this is funny coming from an engineer, for beauty. Because you cannot inspire people with those boxes. I'm sorry, you can't inspire people with those boxes. So if you want to move people, you've got to inspire them with beauty. And you know, you're going to make the nut for us to crack as Americans is smaller, therefore more quality. You know, and that really is the forefront. But if you don't show them, you know what's a great example is Dan Gainsborough's development in West Concord, Riverwalk, right? And we made these little jewel box houses. Don Powers designed them. What's that?
West Concord, Mass. Yeah.
West Concord, Mass. Sorry, they're you know, they're pretty small. They're sort of passive house. They're pretty much passive house type. They wouldn't meet passive house, and they're really high quality. And he's sold every one except for one now, out of a development of 13 units in this economy. So those houses offer someone, and they do cost way more than Carter's. But I think that that's the leading edge to me is smaller and more beautiful. If you don't make it beautiful, you're not going to inspire people.
Thanks, everybody. Thank you all.